Yes, ma'am.
Good morning. Okay, so in the previous lecture, we had discussed about the crash recovery, right? So, is there any confusion for you? Should I repeat the crash recovery session? We had a table, right? And we had four strategy for we had four strategy that was used by the sending host. Always retransmit, never retransmit, retransmit in state 0 and retransmit in state 1, right? And we had six different strategies that were followed by the receiving host uh, by the different combination of acknowledgement, crash and write procedure. Was it clear or I should repeat it again? I'm waiting for your response. Clear.
Yes, ma'am, it is clear.
It is clear, right? Okay. So if there is any individual complaints about the previous lecture, you can ask me personally at the college, or you can tell me during the lecture that which topic you don't know, right? So we can arrange separate session to clear those topics. Right, so previously we have discussed about the crash recovery, and then we started with the UDP protocol, right? So today we are going to continue about the UDP protocol. First of all, I would like to ask that who were present in the last week. Only two students were there, right? So I want their numbers. Who was present in the last week?
Ma'am, me. Roll
Uh,
number 81
81, and other one?
was 91.
91. Okay.
Yeah.
So I had given you task that you need to discover about the TCP and UDP. Uh, right. So do you have any idea about TCP or UDP? If you don't have, you can frankly say that you don't have any idea. Bhavyanshi? Bhavyanshi, do you know anything about the TCP or UDP?
No, ma'am.
Okay.
Ma'am, it's Bhavanshi, though.
Bhavanshi, okay.
Yes.
Yeah. Okay. So, yes. So, because we have started with the crash recovery, what a crash recovery doing? It was trying to recover in case of crash, right? Whenever a crash happens, what a system may do, right? That was all the possibility, and you can select any of the combinations from the crash recovery combinations, right? Now we have some transport layer protocols, which are TCP protocol and the UDP protocol, right? So let me share the. So today, okay, yeah. So today we are first discussing about the UDP protocol. This is user datagram protocol, right? So In the previous sessions, we have discussed about the connection-less and connection-oriented protocols, right? So, can you tell me what is connection-less? What is a connection-less protocol? Or what is a connection-oriented protocol? Please tell me a definition about the connection-less or connection-oriented protocol. See, these two definitions are very important, right? You will encounter this wherever you're going for the networking.
Ma'am, in connection oriented protocol, we first of all define a path and connect with, like, we will establish the connection.
First, we will establish the connection and then we will send packets on it, right? And in connectionless, we don't establish the connection previously, right? So your UDP is a connectionless protocol. This UDP is a connectionless protocol. Because it is connectionless, you have not previously established connection. It is unreliable connection, right? And because of this unreliability, it is common that you encounter some errors while transmitting your data, right? So it does not perform the error checking, right? It does not have the error checking capability. It does not have the error checking capability. And you can say that it is a very simple protocol because you don't have
about AI.
too many steps to follow, right? In order to establish the connection, right? You just have to send the message and then you just don't bother about whether it is received at the receiver side or not. You just have to send it, right? So it is very simple protocol. And because you don't have to bother about the errors and uh, prior connections, you can say that you have minimum overhead.
And overhead meaning?
Overhead meaning if you are having too many computations to do, that means there is some overhead, right? Any kind of processing that you want, that you are doing, that is called the overhead, right? So if you are given some assignments from C and some assignments from all the subjects and you have to solve all the assignments by yourself, right? That is called the overhead which is on you, right? So in case of UDP, you don't have to check for the error checking, you don't have to route the packet, you don't have to previously establish the connection, you don't have to uh, wait for the acknowledgement, and you don't have to retransmit because you are not waiting for the acknowledgement. You don't bother about whether the packet is received at the receiver side or not. That means you are not waiting for the acknowledgement, right? So because you don't have to wait for the acknowledgement, you don't have to retransmit the packet, right? Because we don't care whether it is received at the receiver side or not, right? So that means we have the less overhead. Clear?
Yes, ma'am.
Yeah. So no retransmission is there.
એમ રીટ્રાન્સમિશન એટલે જ ને કે અમને ડેટા મળી ગયો અને પછી એકનોલેજમેન્ટ આપે એવું?
નહીં જો retransmission એટલે you have studied about the transport layer connection and release and all, right? So આપણે ટ્રાન્સપોર્ટ લેયરમાં શું કરતા હતા કે ધારો કે આ મારી સેન્ડર સાઈડ છે અને આ મારી રિસીવર સાઈડ છે, બરાબર? તો હવે હું અહીંથી એક મેસેજ સેન્ડ કરું છું કે હવે હા અહીંથી હું એક મેસેજ સેન્ડ કરું છું, બરાબર? અહીંથી સેન્ડ કરું છું. આ ન્યૂ રાઇટ પેડ છે એટલે મારે થોડી ડિફિકલ્ટી આવે છે પ્રેક્ટિસમાં લખવાની, બરાબર? તો અહીંથી મેસેજ જે સેન્ડ થાય છે એ સેન્ડ થઈને રિસીવ થયો છે કે નહીં આપણે એની રાહ જોવાના. બરાબર. તો રિસીવ થયો છે કે નહીં એ આપણને કેમ ખબર પડશે? રિસીવર એકનોલેજમેન્ટ સેન્ડ કરશે. એકનોલેજમેન્ટ એટલે શું? કે એક એવો મેસેજ કે જે એવું કહેશે કે હા આ નંબરનો મેસેજ, ધારો કે આ મેસેજ નંબર 1 છે, તો એવું આ મેસેજ જે રિટર્ન આવતો હશે એમાં એવું લખેલું હશે કે આ 1 નંબરનો મેસેજ મેં રિસીવ કરેલો છે. એને કહેવાય એકનોલેજમેન્ટ. બરાબર. તો રિસીવર શું સેન્ડ કરશે? એકનોલેજમેન્ટ સેન્ડ કરશે અને સેન્ડર છે એ આ એકનોલેજમેન્ટની રાહ જોશે. હવે સેન્ડરને એકનોલેજમેન્ટ મળી ગયું, ધેટ મીન્સ મેસેજ ડિલિવરી ઇઝ સક્સેસફુલ, રાઈટ. અને હવે સેન્ડર શું કરશે? એક ટાઈમર સેટ કરશે. ધારો કે મેસેજ સેન્ડિંગ માટે એણે આટલો ટાઈમ સેટ કરેલો છે, ધારો કે એ 10 સેકન્ડ કે 20 સેકન્ડનો ટાઈમ છે, બરાબર. એટલો ટાઈમ સેટ કરે છે. હવે એટલા ટાઈમ ડ્યુરેશનમાં આ મેસેજનું એકનોલેજમેન્ટ આવી જવું જોઈએ. જો એટલા ટાઈમ ડ્યુરેશનમાં એકનોલેજમેન્ટ નથી આવતું, એનો મતલબ એવો છે કે મેસેજ ડિલિવરી ફેલ થઈ છે, મેસેજ રિસીવર સાઈડ રિસીવ નથી થયો. તો આ જે સેન્ડર છે એ ટાઈમ આઉટ થઈ જશે અને આફ્ટર ટાઈમ આઉટ સેન્ડર શું કરશે? ફરીથી મેસેજ સેન્ડ કરશે. એટલે જે 1 નંબરનો મેસેજ હતો એનું રીટ્રાન્સમિશન કરશે. રાઈટ. તો આ રીટ્રાન્સમિશન કરશે અને ફરીથી એની ટાઈમર સેટ કરશે અને વેઇટ કરશે ફોર ધ એકનોલેજમેન્ટ. એન્ડ ઇફ ધ એકનોલેજમેન્ટ ઇઝ રિસીવ્ડ, સેન્ડર ઇઝ નાઉ ઓકે, યસ ધ મેસેજ ઇઝ રિસીવ્ડ. તો હવે એના પછીનો મેસેજ હશે એ તે સેન્ડ કરી દેશે. ઇઝ ઇટ ક્લિયર અબાઉટ ધ એકનોલેજમેન્ટ એન્ડ રીટ્રાન્સમિશન?
યસ મેમ.
Barabar. Because we are not previously establishing the connection, that means we don't care about the flow control. So your UDP protocol does not provide the flow control, it does not provide the error control, and it is generally used for the broadcasting and multicasting, right? So where the UDP protocol is useful, generally if you want to broadcast your message, you just send it, right? And then you don't want the acknowledgement, because whenever you are broadcasting, you are sending your message to multiple number of receivers, right? So obviously you are not waiting for that many number of acknowledgement, right? એટલા બધા message receive કરવા, that will create another overhead, right? So in this case, whenever you want to broadcast, your UDP protocol will be good, right? So whenever you want to broadcast or multicast, you will be using your UDP protocol. And here we don't wait for the retransmission of the data. Right? Are you aware about the header? What is the header? Header for any protocol, any packet.
યસ મેમ.
What is the header?
એમાં સોર્સ અને ડેસ્ટિનેશનની ઇન્ફોર્મેશન હશે કે ક્યાં જશે મેસેજ એવું.
Sorry. हाँ बराबर.
ટૂંકમાં મેસેજની થોડી ડિટેલ્સ
Details
હશે.
હશે. Yes. તો તમારું જે OSI લેયર છે, OSI લેયરમાં દરેક લેયર ઉપર, સપોઝ આઈ એમ સ્ટાર્ટિંગ ફ્રોમ ધ એપ્લિકેશન લેયર અને હું સેન્ડ કરું છું મેસેજ, તો પહેલો મેસેજ એપ્લિકેશન લેયર પરથી સેન્ડ થશે અને બીજી સાઈડ એપ્લિકેશન લેયર પર મેસેજ રિસીવ થશે. તો જ્યારે બી એપ્લિકેશન લેયર પર મારો ડેટા ગયો એટલે એ ડેટા વિલ બી કોલ્ડ એઝ અ પેલોડ, રાઈટ? એન્ડ એટ each layer, the layer will be adding one header, right? So there will be a payload and there will be a header section, right? And suppose this is the header for the okay. So suppose this is the payload. For all the layers, you will be having one header section, right? So first of all, in your OSI layer, you have the application layer. Then you have which layer you have after application layer? In reverse order, right? We start from the physical. What is the second last layer? You have studied the OSI layer in the previous semester, right? Yes or no?
Yes, ma'am.
Yes.
ક્વેશ્ચન શું હતો?
Application layer પછી કયું layer આવે? Second last layer. If you start from the physical, after physical you have the data link layer, right? And then the last layer is the application layer. After
યસ
application
મેમ.
layer, which layer you have?
પ્રેઝન્ટેશન.
Yes, presentation layer, right? So for each layer you will be having some header, right? So when you start at the application layer, there will be one header. Then this part will be a payload for the next layer, right? And here you will be having some another header for the next layer. Similarly, this part will be a payload for the next layer, and you will be having one more header. Suppose I have reached the transport layer, right? So at the transport layer I have this header, right? Then this will be a payload for the next layer, and after transport layer I have the network layer, and it will be a header for the network layer, right? So similarly, when I start from the OSI layers, and if I travel through all the 7 layers and I reach the physical layer, right? And then data is transmitted through some channel, and my data is received at another end, and there will be some another physical layer, right? Right? So આ થયો આપણો સેન્ડર પાર્ટ. આ સેન્ડર છે અને અહીંયા આપણું છે રિસીવર. તો સેન્ડર પાર્ટમાં ઓએસઆઈ લેયરના બધા લેયર શું કરશે? એક હેડર એડ કરતા જશે, રાઈટ? તો ઉપરના લેયરનું જે પાર્ટ છે ઇટ વિલ બીકમ અ પેલોડ, અને એક હેડર એડ થયું, અને એ હેડરની સાથે એક બીજું હેડર એડ થશે નેક્સ્ટ લેયર પર. એવી રીતે હેડર એડ થતા જશે. And at receiver side, what it will be doing, it will remove one header at one layer. So at physical layer, it will remove physical layer header for the physical layer, right? For at data link layer, it will remove the data link layer header, right? At network layer, it will remove the network layer header. So one by one, एक header निकलता जाता है, right? So for each layer, you will be having some header, right? Because we are discussing about the transport layer, we will be following some protocols, right? Either it will be a UDP protocol, either it will be a TCP protocol, or some other protocol, right? So for each protocol, you will be having some header format, right? So આ બધું મેં કેમ explain કર્યું? To explain how the header works. Is it clear now? Why we are having
યસ
headers
મેમ.
for each protocol? Because at each layer we remove one header, right? So for each protocol we are having the header, because each protocol is working at the different layers, right? The receiver side एक header remove થતા જતા, right? So for UDP protocol you are having the header of 32 bits, right? So there will be 4 sections. Right. So first section will be a source port. Second section will be a destination port. Third will be UDP length. and this will be a UDP checksum, right? So source port will be a port from your source machine, right? Destination port will be a port from your destination machine, right? And UDP length will be consisting of the length of your UDP protocol, right? So how much long your length of your UDP payload, and it will be including your UDP length will be including 8 bytes of header and the data, right? So length of the data as well as length of the 8 bytes header will be included in the UDP length, and the UDP checksum is optional, right? So sometimes this is included, sometimes it is not included as per the requirement, right? And this checksum is, what is the checksum? Are you aware about the checksum? Yes or no?
No, ma'am.
Okay, so I think you should have studied about it in the previous semester, but see, this checksum is part of the, I think, data link layer or somewhere else, right? But you just, as of now, you just consider the checksum is a value which is telling you whether the error, in order to identify the error in the particular packet, right? So UDP protocol does not provide the error checking, but a little bit initial error checking is there, right? But it is not so reliable, but it is providing some kind of initial error checking, right? So checksum always gives us some value, right? So if a checksum is computed, so we will be discussing about the checksum in the upcoming lectures in detail. But as of now, you just consider it as some value, right? So you have computed some value and you just store that value in this part, right? In order to check the whether the particular packet is having some error or not, right? So if the checksum is not computed, you just store zero in it. And if a checksum is computed, you put some ones in it, right? So depending on the value, you have to add number of ones in this checksum part. So how checksum is
મતલબ મેડમ એ ઓકે હશે આપણું પેલોડ તો 0 નહીં તો 1.
નહીં. જો તમારે એરર ચેકિંગ કરવું હશે તો એમાં કંઈક વેલ્યુ હશે. એ વેલ્યુને તમે સેન્ડર શું કરશે, એમાં કંઈક વેલ્યુ એડ કરશે, બરાબર? અને રિસીવર સાઈડ ઉપર તમારે પાછું ચેકસમ કમ્પ્યુટેશન કરવાનું, કેલ્ક્યુલેટ કરવાનું, અને રિસીવર સાઈડ ઉપર તમારે જોવાનું કે આટલું જ ચેકસમ આવે છે કે નહીં. જો એ સેમ આવશે રિસીવર અને સેન્ડરનું ચેકસમ, દેટ મીન્સ એમાં કોઈ એરર નથી. એ ટાઈપનું કોઈ ચેકસમમાં હોય, બરાબર? અને જો તમારે એવું કંઈ ચેક કરવું જ નથી કે ભાઈ એરર આવે તો બી ઠીક અને ના આવે તો બી ઠીક, તમારે કોઈ મતલબ જ નથી એરર સાથે, તો તમે એમાં જસ્ટ ઝીરો મૂકી દો. યુ ડોન્ટ કેર અબાઉટ ધ એરર, રાઈટ? તમે આ પાર્ટ છે એ ઓપ્શનલ છે. ઇફ યુ વોન્ટ ટુ કેલ્ક્યુલેટ ધ ચેકસમ યુ કેન એડ ઇટ, એન્ડ ઇફ યુ ડોન્ટ વોન્ટ ટુ કેલ્ક્યુલેટ યુ જસ્ટ પુટ ઝીરો ઇન ઇટ.
ઓકે મેમ.
Right? So હવે તમે એની અંદર જો ઝીરો મૂકી દો, so that means you don't care about the quality of the data, right? So સેન્ડરે ડેટા સેન્ડ કર્યો પણ રિસીવર સાઈડ જે ડેટા રિસીવ થયો છે એની ક્વોલિટીથી તમને કોઈ મતલબ નથી, એનો મતલબ એવો થયો, રાઈટ? So this was the UDP header format, the easiest header format. ખાલી ચાર પાર્ટ છે: સોર્સ પોર્ટ, ડેસ્ટિનેશન પોર્ટ, UDP લેન્થ અને UDP સેક્શન. 32 બીટ સાઇઝનું હેડર છે. લેન્થની અંદર શું ઇન્ક્લુડ થશે? લેન્થની અંદર ઇન્ક્લુડ થશે 8 બાઇટ્સ ઓફ હેડર એન્ડ ડેટા. જનરલી DNS સર્વર્સ છે, ડોમેન નેમ સિસ્ટમ સર્વર્સ છે, એ લોકો UDP પ્રોટોકોલ યુઝ કરતા હોય છે. because we need a faster computation, right? So DNS server પર overhead બહુ વધારે હોય, so in order to reduce the overhead they use the UDP protocol, right? પછી તમે જો તો વિડીયો કોલ કરતા હોય આપણે, તો વિડીયો કોલમાં ક્યારેક આપણી ઇમેજીસ બ્લર આવે છે, એમાં UDP protocol યુઝ થતો હોય. They don't care about the quality of the video which is received at the receiver side, right? So sometimes voice is breaking, sometimes video is blurred, and all, right? So they are using the UDP protocol. So I think it was all about the UDP protocol. Let me just check something is remaining. યસ, હવે આપણે શું છે, આપણી પાસે એક યુડીપી ડમ્પ રિસીવ થશે. આવો ક્વેશ્ચન આવી શકે. સપોઝ આઈ હેવ અ યુડીપી ડમ્પ લાઈક ધીસ CB840000T 001C, રાઈટ? આવી કંઈક વેલ્યુ આપણને આપેલી હશે ઇન ધ question, right? So what you have to do, you need to find out what is the source port number. You need to find out what is the destination port number. Right. So let me just erase. Right. We need to find out source port. Second, we need to find out destination port. Then you need to find out length of the datagram. Let us take one by one, right? So if you are given, this is called a UDP dump, right? For UDP, if this value is given, you need to find out the source port and the destination port, right? So the source port is the first four hexadecimal digits, right? So you have CB84, right? This is your source port number, and if you convert this hexadecimal digit to the decimal digits, you will find out the source port is 52100, right? So you can convert it hexadecimal to decimal. You will find out that so first four digits will be your source port, right? And then the second four hexadecimal digits will be the destination port. So this is 000D is your destination port. The third four hexadecimal digits, which is here 001C, to define length of the whole UDP packet, right? So here 001C, and this is a hexadecimal digit. It will be of 28 bytes, right? So this will be defining your length of the UDP packet. So if you are asked that which part is showing the length of the UDP packet, you will be telling that 001C is showing the length of the UDP packet. And you need to second you need to find out length of the data, right? So the length of the data is the length of the whole packet minus the length of the header, right? Because you have the length of whole packet is 28 bytes, and as we have discussed previously, we have 8 bytes of header, right? If you want to find out length of the data, you can say that your length of the data is 20 bytes. Right. So this will tell you the length of the whole UDP packet, and you need to subtract 8 from it, and you will find the length of the data. And here, because of 000D, which is the port number, destination port number, okay, here it was 000D. This means 13, right? Yes or no? 000D means 13. All of you know, right? Yes or no?
Yes, ma'am.
Okay. So here this is telling us that destination port number, right? So 000D means 13. So this is the destination port number 13, and the port number 13 is a well-known port, right? So we generally write the port numbers in your exams and all, right? So for FTP you have this port number, for this protocol you have this port number. So this is the destination port number, and for client server communication you generally use this port number 13, right? So from the UDP dump, you can find out all these things, right? First four digits will be source port number, second four will be destination port number, third four digits will be whole UDP length, and from the whole UDP length, you can find out the data length, which you will find by subtracting 8 bytes from the whole data length. So 20 bytes will be your data length. Okay, so I think this was all about the UDP protocol, and then we have to discuss about the disadvantages of the UDP protocol, because we are having lack of time. We will not be able to discuss about the TCP protocol. We will be discussing the TCP protocol in the next lecture. So let us list out all the disadvantages. Right. So first of all, as we have discussed, it does not provide error control. So this is one disadvantage. Second, you have it does not provide the flow control. This is the second disadvantage. And it do not establish the connection before sending the data. So this is known as the connectionless protocol. So because this is also one disadvantage, because of this, because it is not establishing the connection, we don't have the reliable delivery, right? So you can say that it is unreliable, right? So it do not wait for the acknowledgement, and it do not retransmit the data. All this thing your UDP is not doing, right? Do not get confused with this. It does not provide the error control, does not provide the flow control, it is unreliable, it does not provide the acknowledgement for the sent packet, and it do not retransmit the data. All these are disadvantages. Yes, now if you are having any questions, you can ask. We have 5 minutes. You can ask if you are facing any difficulty in understanding this topic. Yesterday, DCS 150. What is the problem? DCS 150. DCS 150, Neil Kumar. Neil Kumar, are you there? Am I audible, students?
Yes, ma'am.
Okay, so if you have no more questions, you can type no in the chat box, right? If you are having any questions, you can ask. If you want to explain me anything, you can ask. If you have no more questions, please write no in the chat box so that I can find out that yes, the topic is clear. Okay. I want to share one thing that most of the students have written the question in the unit test 1, which was transport layer connection, establishment and release, right? So almost all of you have attempted this question and all of you have written the connection establishment and release for TCP protocol, which is not yet covered in the class, right? So you all will be losing marks for this. Only a few number of students have written the connection establishment and release, the common one in the transport layer which we have. Right, so in the next lecture we will be covering the TCP connection establishment and release, which you all know about it. Right? I am following the book. Let me tell the name. Andrew S. Tenenbaum, fourth edition. I have this book. Book name I am writing over here. Okay. Computer network. Book name is Computer Network. Any edition you can use, and author is Andrew S. Tenenbaum, right? So online versions of this book is available on the internet. You can download this book. This is very good book. If you are having any doubts, you can read from it, and you can also ask me. Okay, all of you please stay in the meet link. I'm taking your attendance. Thank you everyone. You can leave now.